Howdy, it's Andrea, and this video is kind of just a culmination of our systems of equations. I really just wanted to kind of bring the concepts from basically from Unit 14 full circle. When we are solving systems of linear equations, we talked about the fact that we have three different ways that we can solve, right? We know that we can solve by graphing, using substitution method, and using elimination method. Now, this was an activity that I use in class, and I thought what I would do is just illustrate one of these. There's 4 on this activity actually, and I will be posting this on Canvas so that you guys can try a couple of the other ones if you'd like to. It's just optional, but wanted to kind of have that available if you guys wanted to. But I wanted you guys to see that it doesn't really matter which method we use, we are going to get the same solution. Okay, so I wanted to just try that with this example. This is number 2 out of 4. All right, so I'm just going to start off by numbering these guys. Number 1, I think this will just use pink here for number 2. And you can see on this sheet, in this first part, I'm going to be solving by graphing. I've got this graph here at the right. Down here, I'm going to be using substitution. And then over here, I'm going to be using elimination. And we should get the same solution. Okay? All right, so now by graphing, I want you guys to notice too that we have our x and y on the same side of both of these equations. When that happens, I think a really great way to graph in that situation is by using our intercepts. Okay, it's a real easy way. Of course, with our intercepts, we know that when x is 0, we need to find our y. That is our y-intercept. And our x-intercept is going to be the opposite. So I'm going to take this first equation here, right? Bring that down here. And let's see what happens when x is 0. Looks like when x is 0, y is going to be 4. And let's see what happens when our y is 0. So that's going to go away. And x is going to be 8. Okay, that was nice and easy. All right, now let's do the same for our second equation. Let's find y when x is 0 and x when y is 0. All right, so here we go. 0 plus 3y, 9. So when x is 0, y is 3. And when y is 0, x is equal to 9. All right, well that was actually a pretty simple way to do this. Now let's go ahead and graph our intercepts. Since I'm already using pink, go ahead and graph number 2. So we have our y-intercept here at 0, 3, our x-intercept at 9, 0. Now, I can connect these lines. I'm just going to go ahead and do that. Or connect these points, I should say. But I want you guys to notice that there is a lot of room for error here in terms of whether I'm crossing every coordinate and every grid line exactly when I only have 2 points, right? So one of the things that I can do just to assure myself that I am going through every single crossbar, every single grid line where I need to, is to rewrite these equations in terms of y is equal to mx plus b. Because if I do that, then I can use my slope from one of the 2 points that I have already graphed and make sure that my points are exactly where they should be. All right, so let's do that. If I were to rewrite this, I'm going to be moving that x to the right, and I would have 3y is equal to negative x minus 9, and then I would be dividing everything by 3. So I'm going to actually come down here. I'm going to come all the way down here. So my equation for number 2 in its simplified standard form in terms of slope-intercept form is going to be y is equal to negative 1/3 x minus 3. Minus 3? That's not right. Plus 3. What happened? Oh, because I wrote that wrong. I was going to say that is not right. It does not go through the y-intercept at negative 3. All right, so I like this because what I can do now is make sure that every one of my lines, or every one of my coordinates, is exactly where it should be. And how we would do that, like I said, is we're going to use the m. And I would just go from this point here. I've already got this point. Now, a negative 1/3, right, means the same as I can go down on my rise and positive on my x, or I could go positive on my y and negative on my run or my x. In this case, I want to go up. I'm going to use this one for right now. So I'm going to go up to 4 on my y, but I'm going to go negative on my x. I'm going to do that again. Up 1 over 3, up 1 over 3, and then I could go, oh no, I don't need to go from that point because I don't have any more room on the right side there. So what this does is it helps me make sure that I have my line going through exactly the coordinates it needs to. All right, so let's go to back to our equation number 1. And if I were to graph my intercepts here, I've got 0, 4, and 8, 0. You can see that if I'm looking for a solution, these two graphs are very, very close together at one point. So it's going to be a really good idea for me to rewrite my equations in terms of our standard form, just to make sure. All right, so negative 4y is negative 2x plus 16. Divide everything by negative 4. Y is equal to 1/2 x plus 4. All right, so I'm going to pay close attention to my m in that equation. So my m is 1, and of course, no, my m is not 1. My m is 1/2. What that means is I can go up on my y, positive on my x, or I could go negative on my y and negative on my x, because a negative divided by a negative is also a positive. So I have both of those choices. I'm going to choose to go up here. Okay, so I'm going to go up 1. That's not right. Something happened here. What did I do? A couple things I think I did. Negative 4. Negative 2 plus 4. I wrote it wrong. Man, I need to be super duper careful here. It just goes to show. But I guess that's actually a good lesson, because what I was doing just now, I was thinking, okay, I'm going to go up 1 and over 2. Do you guys see? If I did that, my points are all out of whack. It doesn't work. So what that did is let me know that I made an error in my math. I don't know why that happened here. Okay, let's go back here. And it's because I copied that problem down wrong. So it is actually a negative 1/2. All right, so I'm going to go back and change this. So I can go up on my y, negative on my x, or negative on my y, positive on my x. One of those two, either one of those choices, I should say. All right, so from the 4, I'm going to choose the up on my y. I'm going to go to 5, and then I'm going to go negative. Okay, and I'm going to try the other direction too. I'm going to go down to 3, but then positive on my x. Down over 2, down. Okay, now we can see exactly where this equation should be, where it should go through. Up and over 2. Okay. Now that was actually pretty helpful, although you can see I still, my lines are still off a teeny bit, but basically here is where the intercept happened. I didn't actually illustrate that very well in terms of where my where my lines went through. Let me just highlight that. There we go. So according to this graph, we see that our intercept is at 6 on my x and 1 on my y. Okay, so we have solved this system graphically and said that that's where those two lines intersect. Okay, so let's actually come down here and try the substitution method. Make sure that we're getting exactly the same answer. Okay, let's bring both of these equations down. Oopsie. 2x plus 4y equals 16, and x plus 3y equals 9. All right, so using the substitution method, we can see that this equation would be a lot easier to rewrite in terms of our x. We're going to try to isolate our x because it's by itself doesn't have a coefficient here that we need to divide out, other than 1, of course. X is equal to negative 3y plus 9. All right, beautiful. So now I have a value for my x right here. I have discovered that it's the same as negative 3y plus 9. So what I can do is go up to my original equation and just plug that value in to solve for my y. So let's do that. Okay, so we're going to plug for x. So I've got 2 times negative 3y plus 9 plus 4y equals 16. I'm going to use a distributive property here. Negative 6y plus 18. And let's combine our y's. Negative 2y plus 18. Bring those constants to the right. And finally, solve for y. Okay, so far so good. If I go back up and check up here, my y is supposed to be 1. So that is promising. And I wrote pretty big, so I'm going to run out of room. That's okay. I'm going to make myself a little bit of room right here to now solve for x. So I'm going to bring this equation down. It's already written in terms of x. So x is now equal to negative 3. Now my y, we can see that we know that our y is 1, so I'm just going to stick in my 1 right here where the y should be. Minus 9 plus 9. X is equal to negative 3 plus 9. X is equal to 6. Okay, I'm very happy about this result because this is what I expect to get. All right, and lastly, let's just try the substitution method. All right, so let's bring these down. Got 2x plus 4y is equal to 16, and x plus 3y is equal to 9. All right, so I know that I have to look for something to modify one of these equations so that I can eliminate one of my variables. And we can see that eliminating our x's is going to be a lot easier than eliminating our y's, because if we eliminated our y's, we have to multiply each equation by the opposite, 4 or 3, to get the 12. Okay, but we can multiply now both of these equations by a -2, or not both equations, both sides of this equation number 2 by -2. Okay, so I'm just going to rewrite this down below. Here's my original. Okay, this is 2x plus 4y equals 16. Basically what I'm doing is just bringing this down. And minus 2x minus 6y is equal to -18. And when I add these together, we can see that indeed our x's do go out, leaving -2y is equal to -18. Nope, not -18. What am I doing? Need some coffee or something. -2. So y is equal to 1. Woohoo! Let's go back up to our original equation. I'm going to write out this second equation, actually. I'm going to plug this, of course. That's what we're doing here. We need to solve for x. So we've got x plus 3 times 1 equals 9. Once again, just taking this value, sticking it in there. So x plus 3 is equal to 9. And when we use our algebra steps here, we get x is equal to 6. So this is just an indication that we did everything correct. This solution here is 6-1 as well, which we're super happy about. So you guys can see that it doesn't really matter which way you choose to solve, you will be getting the same ordered pair as a solution. Okay, I think that's it for now, guys. You guys will have this PDF on Canvas. You can see there's 3, 4, and then I just skipped number 1, so there's number 1 to do as well. So if you're interested in just practicing this concept, please feel free to print that and try it yourself. All right, guys, thanks.